Hey, young man, do you want to see a magic?
Yeah, sure.
Ta-da! Woo! Wow, I have never seen this magic. Don't you remember that Medusa Ada had told us about inertia? It is same as...
There are three Newton's laws, which are Newton's first law, Newton's second law, Newton's third law. Newton's first law states that an object will remain at rest or continue to move with uniform velocity in a straight line unless it is acted upon by external forces. Next, Newton's second law states that the rate of change of momentum of an object is directly proportional to the net force acting on it, using the equation F equals ma. Lastly, Newton's third law states that every action has a reaction force that is equal in magnitude but opposite in direction. Condition: Newton's first law, the object is at rest or moving with constant velocity. Newton's second law, the object is moving with acceleration. Newton's third law, in all cases with two bodies interact, action and reaction react in a different body.
When you travel in a car and your car suddenly apply a brake, you feel a forward jerk, a forward push. It is because initially you were in motion in this direction. Now the inertia of your body will try its best to maintain your state of motion in this direction. When the car suddenly apply brake, your inertia wants that you should maintain your state of motion in this direction. As a result, you feel forward force or forward push. That's why Newton's first law of motion is also known as a law of inertia.
Now let's move to space. In rocket propulsion, the force on the rocket is determined by calculating the rate of change of momentum when the fuel is released. During the initial era of rockets, solid fuels were used as propulsion agents. They increased the overall weight of the rocket, reducing the efficiency of the propellant, which is technically called specific impulse. With the advent of liquid fuels that used cryogenic propellant, rockets were able to generate the same thrust using lesser quantities of fuel. This enabled the rockets to travel more distance in space and discover many things about the universe.
Next is Newton's third law. Newton's third law is every action force has a reaction force that is equal in magnitude but opposite in direction. The application of Newton's third law is motion of a lift. We consider a person standing inside a lift. If lift moving upward at a uniform velocity, the acceleration is equal to 0. Therefore, the total force in y component is equal to 0, meaning that normal force is equal to mass times gravity. Next, if lift moving upward at a constant acceleration, by applying the Newton's second law of motion, total force in y component is equal to mass times acceleration, meaning that normal force is equal to mass times acceleration plus gravity. Lastly, if lift moving downward at a constant acceleration, by applying the Newton's second law of motion, total force in y component is equal to mass times acceleration, meaning normal force is equal to mass times gravity minus acceleration.
Here is the subtopic 4.2 question solving. Whenever we get a question, remember to underline the important information given. Before doing the calculation, we should draw the free body diagram. Make sure all the forces involved place on the correct axis and direction. In this question, it is obeyed Newton's second law of motion, so we will use the formula F equals to ma. For x components, we have F cos 30 degree minus kinetic friction equals 0. Kinetic friction is negative value because it points to the left, and the formula is mu n, so we get the equations 1. Next, for y components, we have F sin 30 degree plus normal force minus weight equals 0. Weight is negative value because it points downward. Let n as the subject, and we will get the equations 2. Lastly, Just make the substitutions of equations 1 into equations 2, and finally we will get answer for F, which is 7.66 Newton.